Welcome. In this lesson, we're going to talk about our very last type of transformation, which is a reciprocal transformation. So what is the effect of a reciprocal transformation? Well, it has the effect of compressing the values of the scale. It has a greater effect on large values than the log transformation. And what is it actually doing? Well, the reciprocal basically means to turn the fraction upside down. That is, the value 4 can be written as 4 on 1. So the reciprocal would become 1 on 4. So just to break that down a bit more, what it's saying is if I'm starting with the number 4 and I want to find the reciprocal for it, well, the first thing that we can appreciate is that 4 is the same thing as 4 on 1 because 4 divided by 1 is 4. To find the reciprocal of it now, I just swap the numerator and the denominator. So I just flip that fraction and I'm going to get 1 on 4. So as we can see here, to find the reciprocal of 4, I'm just going 1 over what 4 is. That's what it means to find the reciprocal. You just go 1 over what that 4 is. It's also to turn the fraction upside down. So the same thing there. Okay, so now if we work through this table here, and I'll show you how to do this on the CAS, but as you can see, we've got a whole bunch of values here, and we want to apply this reciprocal transformation. So what that means is we're going to go 1 divided by each of these values, and that's going to give us the reciprocal. So let's think about this. 2 would become 1 on 2. We know that's how it works. You're just flipping it around, and that's how it is. So 32 would become 1 on 32. 120 would become 1 on 120. Now, hopefully you can immediately see that the bigger the number, the bigger the effect it's going to have. 120 all the way down to 120 is a big shift. It's far, far smaller than 120. Now, interestingly, we have 0.3 here. Now, if I go 1 divided by 0.3, it turns into a bigger number because how many times does 0.3 go into 1? Well, it goes in 3 times with a bit left over. So this actually means that for this small value, it's become bigger, which is very interesting. And we're going to see more of this as we come to our CAS and we do this for ourselves. So as you can see, I've already put in all these values and I've just called it val. And now I'm going to find the reciprocal of the value. So I might just call this r val. And then I'll come down here, I'll hit equals. I'm going to go 1 divided by variables, the val right here. Whoops, if I can do that again, variables, val, there it is. Hit enter. And just like that, we have gotten all our values here. Let's now move all of them over here. So I'm just reading off these. And you can see I've got 3.33. So take note, I started with a very small number, a number that is less than 1 but greater than 0, and it's actually turned it into a bigger number. Interesting. Then we continue on. This one is 0.5. This one is 0.03. This one will be 0.031. This one will be 0. Now I have to 55, 0.018. 0.18. And then the last one here, if we scroll down, will be 0.008. 0.008. Okay, before we move on, let's just appreciate something for a moment. Do you see how the small value actually became bigger, but the very big value became a lot smaller? So the difference between 120 and 0.008, that's, this is a tiny number. I started with a very big number and it went very, very tiny. It had more of an effect, this reciprocal transformation, on 120 than it did, say, on 2, which just turned into 0.5. So what we're going to see is that the bigger the number, the bigger that compression is going to be. But we also have to see, if you've got a very, very small number, a number that's between 0 and 1, by applying a reciprocal to it, you're actually going to get a bigger number. We're going to be seeing all this in action graphically in the next section.